A very good afternoon to respected Principal Madam, Dr. K. Padmalata, convener of this faculty development program, Dr. A. Suhasini Garu, today's resource person, my dear colleagues, and all faculty members and research scholars who participated in this virtual faculty development program. I, Dr. S. Venkateswar Rao, IQAC Coordinator, Vijaya Institute of Pharmaceutical Sciences for Women, on behalf of Principal Madam and faculty members of VIPW, it's my pleasure to welcome you all to this third day faculty development program on research methodology and data analysis. The main objective of this 5-day faculty development program is to enhance the knowledge of faculty and research scholars in the domain of research and data analysis. Today's topic main aims to impart capabilities of formulation and testing of hypotheses, the nature of the research, to enable the participants to select suitable research design. First day, Dr. Anabalagan sir gave the presentation on selection of research topic and proposal writing, and we all learn about how to write the research proposal for funding agents and grants. Yesterday, Dr. T.E. Gopalakrishnamurthy Garu delivered a lecture on research design and data analysis. Sir, DOE demonstration using Minitab software enhanced our learning process and made it more interesting. Today, Dr. Suhasini will be giving us the opportunity to learn about hypothesis and statistical significance in scientific research. It's my pleasure to invite today's speaker, Dr. Suhasini Garu. Dr. Suhasini earned her degree from PB Siddhartha Arts and Science College, Vijayawada, followed by MSc from Acharya Nagarjuna University, Guntur. She was awarded doctoral degree in Department of Statistics from Nagarjuna University, Guntur. She had published 6 research and review articles in peer-reviewed journals and presented 8 papers at national and international conferences. She has attended 4 conferences, 2 seminars, and 4 workshops at national and international level. She was invited by the ANR College, Gudiwada, and SRR College and CVR College, Vijayawada, for deliver the guest lecture to the students. She has been external examiner and paper setting member for UG and PG programs at various colleges like Mary Stella College, Vijayawada, Andhra Loyola College, Vijayawada, KBN College, Vijayawada, JMJ College, Tenali. Madam expertise in data analysis using SPSS and R programming. She also appointed as a master trainer in Census of India in 2011. Madam also convener for NAC Criteria 1, Feedback Committee, Internal Examination Cell, Poor Student Union Committee, and also the member of IQAC Scholarship, Talent Search Committee and Calendar Committee. She is having 13 years of teaching experience and presently working as an assistant professor and HOD in Department of Statistics, Sri Durga Malleswara Siddhartha Kalashala, Vijayawada. Thank you, madam, for accepting our invitation. Now, I request Dr. Suhasini Garu to hand over the session or to begin the session.
Good afternoon, one and all. Myself, Suhasini. I am Assistant Professor, HOD, Department of Statistics, SDMSME. First of all, I would like to thank SRK Foundation and Vijaya Institute of Pharmaceutical Science for Women. And first of all, I would like to thank Dr. K. Padmalata Madam for giving this opportunity for me, for participating and delivering my presentation in hypothesis and statistical significance in scientific research. So,
Madam, could you please share your presentation, madam?
yes, sir. Is it sharing, sir?
Yeah, madam. Visible, madam.
So right now, today, I want to share my presentation on the topic hypothesis and statistical significance in scientific research. So first of all, we have to know about what is hypothesis. So it is nothing but an assumption. What it means, it is a statement about what you believe today's truth. So we know in general, in our surroundings, what is good, what is bad, and which one is correct, which one is wrong. So basically, we are taking one assumption based on what in our surroundings is going on. So whether it can be proven or disproven by using the research, this is nothing but hypothesis. Next, what is testing of hypothesis? So it is nothing a process of decision making by various statistical tools, statistical methods, and theory of probability. So anti-statistics came from theory of the probability and sampling distributions and statistical methods. So we can see these all come from the testing of hypothesis. And for this, in basic terminology, what we use is, first of all, we want to know the basic term, that is population. What is population? So population is nothing but entire that want to draw conclusions. In example, the group of people, the group of items, the group of observations, everything comes under population. So, and the subset of the population is nothing but a sample. So population can be denoted as capital N and sample N can be denoted as small n. And the parameter which can be taken from population is nothing but mu. And the sample mean, that is X bar, is taken from the sample. So in our research terminology, a population does not refers to the people. It can make many group containing elements of any you want to study, such as objects, events, organizations, countries, spices, anything you can take. You can take whatever you want to the population. Example, I want to say population as the group of students, the group of research scholars who are doing research in any area, the group of measuring the average income of family, like that, anything you can take. It is nothing but population. So if you want to calculate everything, entire population, sometimes the population may be large. In that case, we go for random sample selection. So based on that sample, we can give the conclusion based on the entire population. So what is statistical hypothesis? It is nothing but a certain statement about probability distribution of random variable or a certain distribution statement about population. So we can take from the population or from random variable. We have three types of variables: univariate, bivariate, trivariate. If you take only single variable x, then it comes under univariate. If you can take two variables, that is x and y, it can taken as two random variables. If you can take multi, that is x1, x2, x3, like that, it can known as multivariates. So in our assumption, statistical hypothesis, the statement about probability distribution of random variable, or you can take a statement from the population. Usually it can be denoted as H. Example, we can take average lifetime electric bulb manufactured from a company. So it gives the assumption that can taken as 100 minutes or 100 hours, like that. Then we can take H taken as mu equal to 100. Previously, I have told to you what is the mu. Mu means nothing but population parameter. That's why in statistical hypothesis, H can be represented as H equal to mu. Mu must be population mean. Here mu taken as 1200. Like that we can define. And next, we go for So we go for, it is nothing but I have told to you the statistical hypothesis. Now I have to explain about simple statistical hypothesis. It is nothing but we can give the specification for the entire complete population here. Here the population distribution, the probability distribution is known to us. Here the parameter of the population is clear and gives the known values. Example, if you take any, you can take the mean, that is 100 or 500, that is average lifespan of the fish, average lifespan of the anything you can take that can be represented as H, that must be mu equal to 100. So coming to the composite statistical hypothesis, it can say it does not specify the complete population. It can use, that is mu can be taken as less than 100 or greater than 100 or H not equal to 100. Here we can represent it as the, it cannot give complete specification for the entire population completely. So coming to the main in the research concept, main key role what is playing is, the major key role is null hypothesis and alternative hypothesis. So null hypothesis means nothing. It has no difference with and it can represent null attitude and it's denoted by H naught. So if you test any drug you can take, so is there a, and you can compare with any other drug. Recently COVID and previously pan-academic, so many drugs are coming. So many clinical labs are produced many drugs. So we can compare, is there any difference between this drug and that drug? So if there is no comparison, no difference is there, then we can say it as null hypothesis and it can be denoted as H naught. Next thing, alternative hypothesis. Alternative hypothesis means which is nothing but complementary to the null hypothesis. It can represent it as H1. That means mu not equal to whatever we take the value, that one. That means example I can write here mu not equal to 100 and you can write as mu greater than, mu less than, like that. So it is entirely different to the null hypothesis. What is null hypothesis means? When we test it has no difference, but in alternative hypothesis it has a difference. Some minor error is something is there, like that we are saying about the alternative hypothesis. Next, coming to the, we have in testing of hypothesis mainly two errors, that is type 1 error and type 2 error. In the type 1 error, we can say the rejection, the null hypothesis, that is the null hypothesis can be denoted as H naught when H naught is 2 and it can be represented as alpha. And similarly, the type 2 error is nothing but it is the error of accepting the null hypothesis when H naught is false. That means here it can be represented known as type 2 error and it can be denoted as beta. So these are the major key role playing which the errors in the testing of hypothesis. One is type 1 error and second one is type 2 error. So it in here type 1 error is also known as the level of significance. So the probability of type 1 error is nothing but level of significance. Basically for any problem you can take, so we can take in at alpha % level of significance. That is in basically we can take alpha represents the level of significance. That means default we can take 94%, 99%, 90% like that. 1 minus alpha % we are taking. So such a thing is known as also critical region here. And next thing, when I go for further topic means power of the test. It is nothing but power of rejecting the hypothesis H naught when H naught is false. Here the power of the test is denoted as 1 minus beta. So next we go for one-tail test. One-tail test means
tomorrow should start unit 2. I should check to what is there in unit 2. DBB, question.
Please carry on.
Okay. So one-tail test, it is nothing but unidirectional hypothesis where the area is rejection. If you take the right tail, then it can taken as right one-tail test. So the part of the right tail must be taken as rejection region. Similarly, you observe the diagram when you take in the left side, green colors indication, this can be represented as the left tail test. Here that part can be taken as rejection area. Similarly, while we go for two-tail test, it is nothing but non-directional. For one-tail test, it can taken compared as and it called as directional, and two-tail can be taken as called as non-directional hypothesis. Here we can concentrate on checking whether the sample is either greater or less than the range values. You observe on the screen here, the two-tail can be seen on the screen. We use the two-tail test for using using the null hypothesis testing. While doing the problem, we can take the values based on the one tail and two tail test. Similarly, coming to the point of critical values. So default, I told you previously that we can take the confidence intervals that is 1 minus alpha percent, that is 5% or 1% level of significance. So basically, I can take the standard normal tables, that is the range of 5% is Z. Z is nothing but standard normal variate. That means Z equal to X minus mu by sigma. Here X is the variable, mu is the mean, and sigma is the standard deviation. So Z lies between minus 1.96 to 1.96. Based on the standard normal table value at 5% level of significance, that is 0.95, it must equal to probability of minus 1.96 to 1.96. So based the problem, when we take the value from the normal tables, when the value is greater than, then we can say H naught may be rejected. That is, based on the given problem, we can conclude that when the mod Z value compared, mod Z indicates here what the problem was given to us, that is Z calculated value less than or equal to Z tabulated value. Here 1.96 indicates the Z tabulated value at 5% level of significance. So if the mod Z less than or equal to 1.96, then we can say exactly H naught, that is null hypothesis may be accepted. Otherwise, if mod Z greater than 1.96, the null hypothesis H naught may be rejected at alpha percent level of significance. That is, here we have taken alpha as 5%. Similarly, for 1% I have shown on the screen, that is Z lies between, the table value is minus 2.582 plus 2.58. At 1%, that means 99% here we are taking. Here the value is, if the Z greater than 2.58, exactly the null hypothesis can be rejected. If the modes are less than or equal to 2.58, then exactly we can say null hypothesis H naught was accepted. Similarly, types of hypothesis testing. So there are several types we have in hypothesis testing. So many based on the data or whatever we have to see, we choose among different hypothesis testing methodologies. Here we have to start the use of hypothesis testing toward the research methodology. First one, normality. Here normality is nothing but, here you can represent it as normal distribution. The shape of the normal distribution is bell-shaped curve, and here the mean, median, mode all are coincide here. So default in for any research further, if it can take the area property value mu plus or minus 3 sigma, that must be equal to 0.9973. That means here up to 0.9973% we can accept. Otherwise, we can reject. How much part we are rejecting? 0.9927% we are rejecting. So based on this normal distribution plays a very important role for statistics. For any research you can see. So this part can be taken as a main mandatory for assumptions and everything. So here the data, if the in this probability concept in normal distribution, so the mean, median, mode all are coincide, and it gives the mean is equally likely to say. And here when compared to the t-test, so t-test is nothing but it can, when the sample size, here in the testing of hypothesis we go for, it can based on the sample size, that is small n. So if n greater than 30, then we can take n as large sample test. If n less than 30, we can say it as small sample test. T-test must became taken as small sample test. Here we have to use to test to find the confidence intervals of the population. Here, while comparing to the populations, it can be the standard deviation is unknown to us. While going for the Z test, it is a statistical to the means of the two population samples of different, when their variance and known. So variance means here sigma square, here we are taking. So difference between the variance, that is sigma 1 square and sigma 2 square, those two are known. For a Z test, the population is assumption be normally distributed. Here the Z test comes under large sample. Why? Because previously what I told to you, the small sample is less than 30 and the large sample is greater than 30. So while we go for large sample, we can take the test procedure for Z test, that is X minus mu by sigma by root n. So this is due to the, based on the central limit theorem, sampling and everything. So based on those, we considered it as normally distributed. Similarly, we go for the chi-square test. So chi-square test is used to test the population variance. Here, again is the known or assumed population variance. Here, it can be known to us. So why we are using chi-square test means it is to test the goodness of fit of the data, whether it is good or not. Here we have two types, that is chi-square test for independence of attributes and chi-square for variance. Similarly, we go for analysis of variance. Analysis of variance is nothing but ANOVA. So here we compare the data sets of two populations or sample at a time. So analysis of variance was introduced by Professor R.A. Fisher, who is the father of statistics. So he introduced this topic based on the chronological data, economical data. So he has the doubts and problems, whereas for rectifying those things, he introduced this concept. So here, these tests are similar to the t-test or z-test we can use, comparing more than two samples. So here it shows to us the significance difference between the independent and dependent variables. So first of all, what is dependent variable and what is independent variable, we have to know. So basically, dependence means here we are saying it is the outcome or response due to the effect of independent which research predict to explain. So if one person is dependent to other, then he get the result based on what he was dependent on the other. So based on the clinical test like that, so based on the experiments, whatever we can take, so this all comes under dependent variables. While independent means it's stimulus or activity that is manipulated where researcher to create the effect of the dependent variable. They are entirely different in the dependent variables and independent variables. So in the research, whatever in the testing of hypothesis, the variables can be taken from dependent variables and independent variables. So coming to the testing procedure. So here in testing of hypothesis, first of all, what we have seen in the previous slides, that is, first of all, we set up the null hypothesis, whether there is any significance difference between the what we have taken the investigator, that one. Similarly, we have to set up the alternative hypothesis. Next, we have to fix the alpha percent in advance. That means alpha means level of significance. Previously, I told you that is 0.95% or 0.99% default, you can take anything. Next, we have to compute, that is z equal to t minus expectation of t by SC of t. T indicates the test statistic here. Expectation of t indicates mean, and SC of t means standard error, which follows normal distribution with mean 0 and 1 variance. Here, normal distribution follows, he means here z can be taken as standard normal variant. That way here it follows n of 0, 1 and the null hypothesis h1. Next, we go for the last process of testing. We go for the comparison conclusion. In this concept, what are the problem we have based on the calculation what the data was here. So if we got mod z value less than or equal to z tabulated value, so based on that we can accept. If otherwise, if the value which can taken as mod z greater than z tabulated value, then we can reject the null hypothesis. So what is the problems we have? While we are applying for z test, we give the comparisons conclusion further. Next, coming to the same procedure, first of all, we have to determine the null hypothesis and alternative hypothesis. Next, based on the collecting the data, sometimes we collect our own data and we apply the test for projects or research or anything. You collecting current data, whatever we have the information availability to us, you prepare questionnaires and you prepare Google Forms. Through that, you're collecting the data and summarizing the data. So next, you after collecting the information, you are applying the test statistics. After that, which one is suitable? Based on that, you have to calculate the p-values. So in current scenario, p-value plays the key role. P-value is nothing but probability value. So the result, whether the result is statistically significant or not. If the p-value less than or equal to 0.0, then it can say as significant. If the p-value less than or equal to 0.0, we can say. Otherwise, we can say it is not significant. Based on comparison of the level of significance and p-value, when we can say the result is significant when the p-value is less than or equal to the level of significance. Here, level of significance means alpha. Previously, I told to you in the previous slide that is mod z less than or equal to z tabulated value. Like that also we can compare for any problem. Next, testing of hypothesis. So here in testing of hypothesis, we have in Z test many more tests like that: test for single mean, test for proportion, single proportion, two means, single mean. Next, two standard deviation, single deviation, two correlation coefficient, like that many more in the Z test. So in that, here we can, if the null and alternative hypotheses are expressed in terms of population proportion, mean, or difference between two means for sample large, that means I told to you when n is greater than 30, we go for Z test. So these all come under Z, we apply the Z formula. That means Z expectation of Z equal to T minus expectation of T by standard error of T for single. If you take multiple, I mean 2, that means x1 minus x2 minus of expectation of T1 minus expectation of T2 by standard error of T1 minus T2, like that you can take. So here, for our, you can compute the assumption of null hypothesis and the p-values. Previously, I told to you how to calculate the p-value and what is the values we get. If the value is less than so-and-so value, then we can say it is significant. Otherwise, we can say it is not significant. Based on all these, we can compute the testing of hypothesis for proportional and means. Similarly, so we go for confidence interval. That is, I told you alpha % level of significance. That means 1 minus alpha, that means 1 minus y, that's 0.95%. So see the graph on the screen here. What you observe that here the confidence interval shows the probability of the parameter which falls between a pair of values. So you see the outliers is 2.5 and the lower limit is 2.92 and 5.62. So based on the screen here, the points, the confidence interval fall between the 2.92 to 5.62. So we have to constructing whether it is gives the certainty or uncertainty based on the sampling methods. Next, we go for confidence, how to calculate. So X bar is nothing but sample mean. Here Z alpha. Previously, I told you critical values for Z. So there I told you at 5% level of significance, the value is 1.96. For doing calculation of 95% confidence interval, you have to take the formula is X bar plus or minus 1.96 S by root n. Similarly, if you want to take for 1%, that is 99%, then you can write the formula is X bar plus or minus Z alpha means 2.58 into S by root n. So here the notations which we have written the formula are explained below. So for calculating the confidence interval, I give a small example. In a tree, there are hundreds of mangoes. You randomly select 40 mangoes with mean 80. Mean means here average we are taking, and standard deviation, you can take the 4.3, determine the mangoes are big enough. So based on the whatever the formula which I shown in the previous slide, we have to apply 95%, that is Z equal to 1.96 while applying the formula. So lower limit and upper limit, the margin is here, marginal error is 1.33. So the confidence limit lies between the range is 78.67 to 81.33. So this can be comes under all these previously what I do. These are all coming for testing of hypothesis, which we apply for large sample test. So now we go for small sample test. Small sample test is nothing but t-test. So what are the assumptions for conducting students t-tests here? The parent population from which the sample is drawn is normal. So already I told to you what is normal distribution. So normal distribution is nothing but it is a continuous distribution which is in the shape of bell shape, and by compared to the problems and any other thing, we can compare the 99%, 0.9973% we can accept. So in this assumption, the population, the parent population can be taken from the samples which are drawn is normal, and the observations are all are independent. Example, you can take x1, x2, so on, xn. All these are the samples which can be taken from parent population, that is capital N, and small x1, small x2, small xn are the sample observations, and they are independent. They are not dependent. All the samples which we are taken are independent. And the population standard deviation, which is sigma, it can be known here for the t-test. Similarly, applications of t distribution. So previously I told you t test for single mean, t test for difference of means. Previously in the loss sample test, we go for the testing of hypothesis for z test for single proportion, z test for two proportion, z test for two means, z test for single mean, z test for population mean, like that. Similarly, here also for t distribution also we have t test for single mean, t test for difference of means, paired t test for difference of means, like that. Here when compared, for coming to the point of paired t test, here if you take a drug, so how the effect before giving the medicine to the patient and after the results, you can compare by using the paired t test. In research methodology, in clinical concept, paired t test play a key role. So here we can take it as when the sample size n is less than 30. Similarly, we go for F distribution. It can use the applications of equality of two population variances, and F test for testing the linearity of regression, and F test for equality of several means. So these are the theory part which I want to share to you. Now I go for problematic. Anybody have any queries regarding what I gave to you?
After completion of the session, they will post it in the chat box, madam.
Okay.
Or somebody they will ask directly. They will ask the queries, madam.
Okay, sir.
Yeah.
Here, I was taking a problem that is 20 people were attacked by a disease and only 18 were survived. Only people were attacked by a disease. So, and only 18 were survived. So, will you reject the null hypothesis that the survival rate if attacked by this disease? That is the question we have to find out. So here n means here n equal to 20, and here x equal to how much? 18. So based on the available information, we can construct the proportional value p equal to x by n. That means 18 by 20. Then you get the value is p equal to 0.9. So based on the here they gave the 85% in favor of hypothesis, that is more at 5% level of significance. 5% level of significance means we go for 0.95%. So based on the given information, what is the formula is z equal to p minus p naught divided by square root of p naught q naught divided by n. So based on the given information, we have to apply the formula for this data. So already now here we calculated the p value here. P can be taken as 0.5. And here what is p naught means? In the question they gave asked for us 85% in favor of population. So that's why here we are writing the p naught as 0.9 minus 0.85 divided by square root of P naught means 0.85. Q naught means here Q naught must be taken as 1 minus P naught. That means 0.85 into 0.15 divided by 20. So you get the result 0.633. So at 5% level of significance, what is the value we have for the problem which was given to us? That is nothing but the Z tabulated value is Z equal to 1.645. So based on the Z calculated value which we get the result is 0.633. So and what the tabulated value is 1.645. So here clearly it shows that 0.633 less than 1.645. Hence, we can say that H naught is accepted. So this is the example for Z test for the population proportion. So while I go for the means problem, that is example, we can say t-test for single mean, t-test for single mean and t-test for two means. So we gave the problem for proportion, single proportion. Now I want to explain to you for two test for two means. That is, here the problem can be taken as again, I'm taking another problem, CLFU. Here, in a random sample of size, that means size means n, here we are taking 500 and the mean is found to be 50. Mean means here sample mean we are taking, that is x bar. X bar can be taken as 30. In another random sample size here, that is you can take n2. So here 2 means I told you, that wise here we are taking 2 samples. That means sample size n1 can be taken as 500, and for that population we are taking x bar equal to 30. And for going for the another, we go for sample size n2 must be taken as 400, and the mean can be taken as, that is y bar can be taken as 35. What we have to find here? What we have to find out here, the sample have been drained from the same population. Already previously I told the parent population, what the samples can be taken must be is normal. So we have to check whether the samples have been came from the same population. So given the notation here, you have to construct the null hypothesis. What is null hypothesis here? H naught mu1 equal to mu2. Mu1 equal to mu2. That means the two samples have been drawn from the same population. Similarly, alternative means what? Complementary to the null hypothesis. That means H1. H1 not equal to mu1 not equal to mu2. So similarly, we go for Z test statistics. Here we are taking how many populations? 2 populations. From first population, we take the sample size n1 as 500. For the second population, you can take the sample size as n2 as 400. And for first population, that is here this is population 1 and you are taking another population. So from this population, so small n1 can be taken as 500 and this is another population. So here n2 can be taken as 400. For the population, which one I can take in the samples is n where the mean is 30, and the population where the samples can be taken n2 equal to 40 and the mean can be taken as 30. So what is our null hypothesis? How we have set up the null hypothesis? The samples have been drawn from the same population. So that's why we set up the null hypothesis, that is mu1 equal to mu2. Similarly, alternative hypothesis, the samples are not drawn from the same population. That means H1 mu not equal to mu2. Next, we have to compute the test statistics. That means Z equal to x bar minus y bar divided by sigma. Actually, I'm writing here I'm using a text box. So here it is not using the notations. That's why I'm writing x bar, y bar. So all the people who are listening my lecture can understand. I didn't use the notations, just I'm writing. So that is 1 by n1 plus 1 by n2. So based on the given information, we have to compute the test statistics. That means here you take the what values we have given in the problem. CLRQ. So x bar can be taken as 30 minus y bar can be taken as 35 divided by. So here the sample here, what we have given sigma value standard deviation is 8. So you have to take 8 into square root of 1 by n1. That means n1 has a value taken as 500 plus 1 divided by 400. So based on the above information which the problem was seen to you, so based on the given problem, we are computing the Z value. So based on this, we have got the value that is minus value. Minus, why? Because 30 minus 35. So we get the value minus 9.32. So when the negative value is coming to the comparative values, minus can be taken as positive. Why? Because here Z can be taken as mod Z. Previously, what I told in critical region for two-tail test, one-tail test, mod Z less than or equal to mod Z greater than, like that I told you. So here minus value can be considered as positive. Why? Because it is the modulus value. Mod minus 9.32 can be taken as positive. So mod Z must be equal to positive value of 9.32. So here the mod Z value comparing to the 5% level of significance, so it is greater than. So that's why we can say our null hypothesis H naught is rejected. The samples cannot be drawn from the same population. This is the example for 2 means. Similarly, for loss sample test, I go for 2 standard deviations. Standard deviations means here what we know, sigma 1 and sigma 2. From the population 1, we can take sigma 1 as first standard deviation, and for population 2, we can take as sigma 2. Okay. Right now, I go for second one. So here, I want to give the problem that I want to explain to you, that is the 2 standard deviations of 2 samples of sizes are 1000 and 500. Here from the first population I can take in 1000, and from second population I can take in as 500. And the standard deviations are taken as here 2.6 and 2.7 C1s. Here the sample size of first population can be taken as 1000 and N2 can be taken as 500. And similarly, the standard deviations here SD, that is can be taken as 2.6 and second population. So it can represent as sigma S1, you can represent. Why? Because it comes from the first population. And similarly, you can represent second standard deviation as S2. That must be taken as S2 equal to 2.7. So how you have to test statistic, how you can compute the test statistic here. First of all, before going to do the problem, based on the problem, you have to set up the null hypothesis, whether the 2 samples have come from the same population. You have to construct H naught. Null hypothesis, that is H naught sigma 1 equal to sigma 2. Sigma 1 equal to sigma 2. Similarly, alternative is what? Sigma 1 not equal to sigma 2. The 2 samples have not drawn from the same population. And you have to go for, you have to compute for test statistic. How you testing the statistic that is under null hypothesis? Previously, we concentrated on the 2 means. That's why you wrote the formula of x1 bar minus y1 bar or x bar minus y bar. But here we are testing the 2 standard deviations. That's why we get the formula Z equal to S1 minus S2 divided by square root of S1 squared by 2n1 plus S2 square by 2n2, which follows with normal distribution n of 0, 1. So by substituting the values, you get the result, that is 2.6 minus 2.7 divided by square root of 2.6 into 2.6 divided by 2 into 1000. Why? Because from the first population we have taken the sample size 1000. That's why we wrote here. Next, similarly, plus 2.7 into 2.7 divided by 2 into, from the second population, the sample size can be taken as 500. So by computing all these, we get the result of 0.9681. Here the value is compared to the 95% confidence interval, that is Z alpha can be taken as 1.96. What you get the result here? 0.9681, which is less than 1.96. Here clearly it shows at 5% level of significance for two-tailed test, H0 may be accepted. That means the samples can be drawn from the same population. So this is the example for two standard deviations. So now I go for t-test. T-test means here we have different topics, that is t-test for single mean, t-test for two means, paired t-test, like that. First of all, I want to explain for t-test for single mean. So first of all, I have to take a random sample of 10 points. Here t-test go, how we can decide whether it is t-test or z-test, based on what? Based on the sample size. Previously, what we have do the two problems, the sample size is 100, 500, like that. That is n greater than. That's why we go for z-test. Now we go for t-test. That means the sample size must be less than. So see, all of you, what is the problem I'm taking is a random sample of 10 boys had the following IQs. IQs means all of you know, that is 70, 120, like that they gave the data. Do these data support the assumption of the population mean? Whatever the data given to the problem, the IQs of the 10 boys is the assumption which is given to us is the for, does the data support to the assumption of the population mean, that is IQ of 100. So they gave the null hypothesis exactly mu equal to 100. See, all of you, here n can be taken as 10. So the IQ levels of the boys, what the data was given to you, to us is 70, 120, 110, 101, 83, 95, 98, 107, 107 and 100. So this is the data which was given to us. Sorry, one observation was missed here, that is 88. So the data was clear. So what was they asked to us? Does the data support the assumption of the population which was taken IQ of 100? So here they gave mu equal to exactly 100. Whether it is satisfying or not, we have to check it. So first of all, based on that, this is the single variable, single data, univariate, the values given in the single digit, single values. I mean, here we have to take the X, we have to calculate the X bar. Based on the given information, you calculate whatever the data was given to us, you have to add the values and divide it by 10. That is example 70 plus 120 plus so on 100 divided by 10. That means what is the result we get? So 972 divided by 10. That means we get the result 97.2. Similarly, based on the given information, you have to calculate the formula of S square, that is standard deviation. So based on the standard deviation, you get the value S equal to 13.54. So now you have to construct the null hypothesis. How you are constructing the null hypothesis? Already previously there was given mu equal to 100. So that's why we set up the null hypothesis, that is H0 mu equal to 100. So the data, the sample data support the assumption of the population mean IQ of 100. Similarly, alternative means what we are saying, the sample data do not support the assumption we are taking. That means mu not equal to 100. So based on the given information, we compute the test statistic, that is T equal to X bar minus mu naught divided by S into square root of So this is the formula for t-test. So what are the information we have? Based on the single observations, we have calculated the x bar. So you have to substitute the x bar value. What we get the x bar value here? 97.2. So already they gave whether you have to test the data came from the same. That's why mu. They gave the mu value how much? 100. So that's why you take what you calculated the value of x bar value can be taken as 97.2 and the mean value can be taken as 100. So divided by, you have to calculate the standard deviation formula, that is 13.54. 13.54 divided by square root of, how many observations here? Sample size 10. So you have to take in as 10 minus 1. So finally you get the result, that is 0.62. So for t tabulated value, we can construct the t tabulated value can be taken as t alpha comma n minus 1. Previously, we can take just z alpha value, that is z 0.05%, z 0.01%, like that. So here you can compute whatever the problem, whatever the sample size we have. So here alpha means here you are taking t alpha comma n minus 1. So here we are taking alpha as 5% level of significance and n as 10 observations, 10 minus 1. So at sample size 9, you have to check the tabulated value, alpha percent 0.09. Based on that, you get the value of tabulated value is 2.262. How to check the value of t tabulated value? See, everyone. Here you have to take in the sample size which was given to us for the given problem. Based on that, you have to minus 1, which is nothing but degrees of freedom, like the take n minus 1, and you have to take in the alpha. Default you can take the 5% or 1%. Sometimes in the problem they were given you have to compute for 0.10%. That means you have to compute alpha as 0.90%. So for the given problem, we are taking it 5% level of significance. How much? At 5% level of significance and 9 degrees of freedom. Why? Because here 9 degrees of freedom, here the sample size is 10. That's why 10 minus 1 we can write as 9%. From the table value, t tabulated value, you have to check the sample size at 9 and at 5% level of significance. What you get the tabulated value here? That is 2.262. What you get the calculated value here? 0.62 less than 2.262. Based on the given information of the problem, based on the computation which was done by us, we get the result, that is 0.62 as t calculated value, and based on the given information we go for the t tables at 5% level of significance. The value is 2.262. That's why while comparing and comparison here, 0.62 is less than 2.262. That's why here we conformly say that the null hypothesis H0 is accepted. That means the sample data support the assumption of the population IQ is 100. This is the what I have to explain to you. Next, secondary. So paired t-test. We go for the paired t-test. CLF. Paired t-test means one person, if we gave the information, that is whether we have to check one drug is given to the patient, how the condition of the patient before he has used the drug and after the using the drug. So we can collect the information. So example, a treatment was given to 10 patients and readings have given before and after applying the treatment. So some patients are going to admit in the hospital. So due to so-and-so problem, anything, whatever you can think. So here based on the information given to the doctor about the patient, he was taken the condition for how much the BP, how much the temperature, everything, how much the weight, everything he can note it. And after he gave some dose to the persons, and I mean the patients, and he collect the information after the drug was used. So now I'm taking that data, CLFU. So here I'm taking the patients as 10 members. Patient can be taken as 10 members. HB percent. Here I am taking HB percent before treatment and HB percent after treatment. So this is the information which I have. So I am taking the information of HB percent of 10 patients before treatment, before when I start the treatment, before. After I have taken that, I started the treatment. I have collected the information. So the values can be taken as 11.9, 11.99, like that. I was taking the information. Out of 10 patients, I collected the data for both before and after. So this is the data of before treatment and this is the data. 9 observations I wrote. 9, 4, 9, 9, 9, 8, 12, 11. Again here the value which was missed with 12.0. So this is the data which was collected HB percent before treatment. Now we have taken the data which was HB percent after treatment therapy. Here we can take the data where 11.99, 11.95, 12.07, 12.03, 11.98, 0.03, 12.02, 12.01, 11.99. So this is the data which I have. So what we have to test here, we have to we can conclude that HB percent was increased after the treatment was given to the patients. This is the condition we have to check. So we have to calculate based on the information. First, we have to calculate D bar. D bar means here, based on the above information, HB percent before treatment can be taken as X and after treatment can be taken as Y. So you have to find out the deviation value, that is D equal to X minus Y. X minus Y means HB percent of before treatment and HB percent of after treatment. Example, 11.94 minus 11.99. Like that, you have to take the values. After that, you have to square it. You have to calculate the D bar. D bar is nothing but what? Summation DI by N. So here, how much the N value here? 10. So you have to calculate, you have to compute the values, each and every value. You have to compute 11.94 minus 11.99. Second, you go for 11.98 minus 11.95. Like that, you have to take 4 columns. After that, you have to compute D bar. You get the value minus here minus 0.31 divided by 10. So based on the above information, you have to calculate D. After that, you have to square those terms. Example, I will say to you once again. Example, if you take the 11.94 minus 11.99, you get the result as minus 0.06. Next thing, you have to square that value. That is minus 0.06 means 0.0036. Like that, you have to calculate for each and every observation. Then you calculate the D bar value. So after that, you similarly previously what I told you, you have to compute the standard deviation for the given information, given problem. Next, we have to compute the null hypothesis. Null hypothesis, how you can set up H0. H0 means what? HB percent was not increased, not even after treatment was applied. So we gave the treatment for the patients. Whether is there any change? No change. So that way we can compute null hypothesis as HB% was not increased, not even after treatment was applied. What is alternative hypothesis here? How we are writing? HB% was increased after given the treatment. Like that, we can construct the null hypothesis and alternative hypothesis. So H0 must be taken as, the first observation can be taken as mu1 and second observations that is taken as mu2. So H0 can be taken as mu1 equal to mu2. Similarly, alternative means H1 mu1 not equal to mu2. Next, you go for test statistics under H0. What is the formula here? T equal to D bar divided by S by square root of same procedure, but something is changed. That is the formula. Which one is? Previously we can compute X bar minus mu, but here we are computing the D bar. Why? Because it is nothing but paired t-test. Here pair of observations was taken. Pair of observations means X1, X2, so on, X10. So for the before and after that, what is the patient condition? What is the, so we can collect the information which was available to us. So based on the data, we can calculate the t value. So based on the above information, we calculated the d value, we get the result minus 2.40. So basically, previously what I told to you that the minus can be converted as positive. Why? Because in the modulus, mod z value can be negative, can be taken as positive. Similarly, here also minus 2.40 can be considered as in the modulus value, it becomes negative also positive. So what is the result? We get t value can be taken as t equal to 2.40. Next, how we can compute the tabulated value here? So T alpha what I told to you 5%, T 5%, comma n minus 1. N minus 1 means what here? 10 minus 1. At 5% level of significance, we have to check the value of 9 degrees of freedom. So we get the 9 degrees of freedom means from the table values 1.833. So compared to this, so compared to this here 1.833, so less than 2.40. So based on the given information, we have calculated and we have tabulated the paired t-test. So the value which we get is t equal to 2.40 and the tabulated value which we get is 1.833. Which one is less than? So hence we conclude that it is rejected. H0 null hypothesis can be rejected. So HB patients, HB% which was not increased after the treatment, we can conclude like that. So similarly, we go for advanced, that is chi-square test. Chi-square test already told to you. So this can be taken to test goodness of it. So this was chi-square test was introduced by Professor Carl Pearson. So he used this method from the theory and also observed theoretical and practical point of view. First, he gained the information based on the observed frequency. After that, he calculated the expected frequencies. Here also, we can compute the null hypothesis to fit the distribution of the given data is best fit or not. Next, alternative, to fit the distribution for the given data is not good fit. Based on the given information, we have to conclude whether it is accepted or rejected. So first of all, what are the conditions for validity of chi-square test? First of all, for chi-square test, the sample observations must be independent. All the observations, whatever you can take, all the observations can be taken as independence, and the total frequency should be large. It must be always greater than 50. It must be always greater than 50, and the number of theoretical cell frequencies less than pi. Here you can see. You can see the data. So 300 students. 300 numbers are drawn randomly with the digits of 0 to 9 from random numbers table, and their frequencies are given. So here we can take the digits. Digits can be taken as 0 to 9. Next, frequency. You can take. Frequency can be taken as 28, 29, 33, 31, 26, 35, 32, 30, 31, 25. This is the data which we have. For the digit 0, the frequency is 28. For the frequency one, for the digit one, the frequency is 29, and the last digit for 9, the frequency is 25. So what we have to set up the null hypothesis H0, that is H0, the digits are drawn equally frequently from the random numbers tables. How the data was collected? It can be collected through randomly. It was generated random selection. So alternative means the digits are not drawn equally frequently from the random number. So based on the null hypothesis, alternative hypothesis, we have to, based on the result, whether it is accepted or rejected, we have to conclude. So based on the given information, you have to calculate the expected frequencies. Expected frequencies means you have to add all the numbers which you have. So the total frequency must be taken as 300, and how many observations here? 10. So you have to divide, you get the 30. So here you have find out the expected frequencies. Based on the chi-square distribution, we have the formula, that is chi-square equal to summation Oij minus Eij whole square divided by summation Eij. So what is Oij and what is Eij here? Oij means observed frequencies. What are the values which was given by the problem? So here the frequencies are taken as Oij's, observed frequencies. And what is Eij here? Eij can be considered as expected frequency. Already here we can take as expected frequency. It is uniformly to all. So every digit has the expected frequency is 30. So based on the given information, you have to calculate the Oij minus Eij. Oij minus Eij. So based on the given information, you have to calculate Oij minus Eij. After that, you have to calculate Oij minus Eij whole square. Example. So first observation, Oij equal to how much here? 28. And what is the Eij value here? That is 30. Then Oij Eij means what? 28 minus 30. What you get the result? Minus 2. So first observation, we get minus 2. That is 28 minus 30. Similarly, you have to calculate 29 minus 30, 33 minus 30, 30 minus 30. Like that, you have to do for every observation. After that, what you have to do, here the formula is Oij minus Eij. Now only calculated Oij minus Eij. After that, you have to square it. That means Oij minus Eij. Next, after that, minus 2 into minus 2, 4, you will get the result. After that, what you have to go forward? Summation Eij. Summation Eij means overall you have to calculate the Eij value. So that can be taken as 30. By substituting this, you get the value, that is 2.8667. Here you get the result is chi-square value. By doing all the above process for the given problem, we get the result is 2.8667. Here also you computing the chi-square value at 5% level of significance at n minus 1 degrees of freedom. Here also we have taken how much sample size? 10. That's why at 5% LOS we are taking 9 degrees of freedom. So the value is 16.92. So how we get the 16.2 value? It is nothing but chi-square tabulated value at 5% level of significance. We can see on the table 9 degrees of freedom. So the value is 16.92. So based on the above information, we get the 2.8667. So chi-square tabulated value is 2.8667, which was less than or equal to 16.92. So for the given problem, based on the given information and conclusion, what we have to give, that is, it was accepted. H0 is accepted. The digits are drawn equally frequently from the random numbers tables. This is the chi-square goodness of So further we go for main thing in testing of hypothesis. We seen on the large samples and small samples. So for next thing is at a time we can't to draw the same at a time. So then we go for ANOVA concept. Already I told you economical data. Economical data is nothing but agricultural fields. At a time we can't select the same populations at a time. We can't do the same samples like that. So in that concept, ANOVA concept can be gone. So here in ANOVA we are saying the best example is, and I want to share you about ANOVA is one thing I want to say, that is ANOVA is based on the test statistic F variance ratio. F variance is nothing but the ratio of the chi-square, that is chi-square distribution. Here also the observations are independent and population, the samples which can be drawn from the same population here also, and the various treatments and environmental effects are additive in nature here. So here we have two types of classifications. How many? Two types. What are those? One-way classification and two-way classification. One-way classification and two-way classification. Here in one-way classification, the treatments can be taken as row-wise and the sample observations can be taken as column-wise. That means here you can write as 1, 2, 3, so on, K treatments. So for first observation, we can take as X11 as first treatment, X12 as second treatment, X12 as second treatment, X13 as third treatment, and X1, N1 you can represent. Similarly, you going for X21, X22, X23, X2N2. Similarly, X31, X32, X33, X3N3. Like that, you go for XK1, XK2, XK3, XKN. So here, in the ANOVA concept, we have two types of causes, that is assignable causes and chance causes. Assignable causes means it can be measured, identified, detected, and we can solve them easily. But chance causes cannot. So they are beyond the control of human hand. So in the assignable causes, we can do modifications, anything. Example, while doing some problems, some errors were erased. So it is man-made human error. So we can rectify it. Suddenly rains and floods are coming. So it is natural. So natural, it is occurred through nature. So we cannot control that one. So here two types of causes. One is assignable causes and another one is chance causes. So now I want to explain a problem for ANOVA one-way classification. See here, it can represent treatments can be taken as row-wise and sample observations can be taken as column-wise. Example, treatment 1. So here some varieties of treatments are applied to so-and-so, or some drugs are applied to the patients. Patients can be taken as column-wise and medicines can be taken as row-wise. Here treatment 1, treatment 2, treatment 3. You have to write here. So based on the information, you have to write the patients. Can be taken as sample observations. Here treatment 1, treatment 2, treatment 3 can be taken as row-wise and the sample observations can be taken as column-wise. Based on the above information, we have to test whether it is accepted or rejected. Based on the information, we go for ANOVA one-way classification. In case it has T1, T2, T3. Similarly, if the columns can be taken as B1, B2, B3. Here T1, T2, T3 represents the treatments and B1, B2, B3 can represent the columns. It can follow the two-way classification here. So that means we have to check whether there is a significant difference between the treatments, and we have to check there is a significant difference between the blocks. So based on the given information, we have to calculate the ANOVA, analysis of variance. So based on the information, you go for treatments totals and for treatment means and for treatments everything. For F variance test, variance ratio also you have to calculate. For both the information which you have calculated, you have to compare with the F tabulated value. So F variance ratio can be taken as calculated value, and you can check the tabulated value from the F tabulated values. So based on the given information, you have to calculate F table value. So and compared to the tabulated value, if you get less than or equal to, then you can go for H0 can be accepted. There is no significant difference between the treatment means. In case there is a something greater than, then you can say there is no significant difference between, like that. Similarly for blocks also. So research methodology, as a research students or research scholars, all our main important concept which you have to learn is chi-square test, large sample test, small sample test. After that, you go forward for multiple purpose, you go for the ANOVA. ANOVA means at a time several means can be taken from the same population. So there it was not suitable, so it was not, so that's why we go for ANOVA concept. So anybody have any queries regarding this session, you can ask me.
Participants, faculty members and research scholars, those who have any doubt, please post it in the chat box. Otherwise, you can directly ask to the resource person.
Actually, we have in the FTP, we have SPSS package and mini tab. That's why I calculated manually to show on the whiteboard. So if you have any queries, we can do all these problems in the Excel sheet also. You enter the data in the Excel sheet and you go forward. If you want to see that, I can explain.
Madam, this explanation on the notepad, madam, that one?
Yes, sir.
Yeah.
Whiteboard, sir. Whiteboard in Zoom.
White. Okay.
Yes.
Whiteboard.
Actually, in whiteboard in this, we can't get the notations, sir. Actually, in statistics, we have the notations we are using. That's why I wrote as a text, sir.
Okay, madam. Madam, what is the difference between the chi-square test and Perry t-test, madam?
Actually, parity test is the comparison of the whatever the result we have of the dose or drug before and after. Based on here, the sample size can be taken as less than, sir. Here it can applicable for t-test, sir, but chi-square is entirely different, sir. It is a whether it is a good good fit or not, we can say based on here. Example, in chi-square independent of attributes, we concentrate on the attribute characteristic qualities, sir. Here employment, unemployment, smoking, not smoking, like that. We can collect the information, both attributes concepts, sir.
Okay, madam. Madam, regularly our pharmacy practice students are doing their project work in the hospital, madam.
Okay.
They are collecting different types of data from the patients, madam, whether it is
Yes,
a hemoglobin concentration.
Yes, sir. So
mainly these
parity
parameters
test is
are
suitable. Parity test is suitable for that, sir, for comparison purpose for clinical side.
Okay, madam. Then compared to the chi-square test, parity test is better, madam.
No, sir. For limited data only, we apply for parity test, sir. That is sample
Limited
size.
means, madam,
Sample
less than
size
50,
less
madam.
than 30. Less than 30, sir.
30.
Yes, sir.
If it is more than 30 means?
Greater than 50 or more than, you can go for chi-square
parity
test.
test.
Chi-square test, sir.
Chi-square test.
Yes,
Okay.
sir.
Sample size is more, we should use that chi-square test.
Yes, sir. Greater than 50.
Okay.
So it is in the what is the data is in the row wise and collect the information based on the patients. I mean, you are collecting the information regarding hemoglobin or other thing. Can you explain, sir? Once I will explain whatever the data you are collecting.
Data means simply it is all parameters related to the disease only, madam.
Diseases. Okay.
Some students collect the parameters related to the diabetes. Some other persons
Many more
collect the
research.
data related to the heart patient, like that, madam.
Yes, sir. Many more research for chi-square is apt, sir. Chi-square is suitable, sir.
Okay, madam.
For clinical purpose, chi-square is more sufficient, sir.
Okay. Madam, in that problem, you have taken one tabulated value, madam.
Yes, sir.
The tabulated value is according to the 5%
Level of, yes, sir.
level of significance.
Yes, sir. Yes,
That
sir.
value is obtained at n-1 value, madam. That
Yes,
is
sir.
related to the n-1 value.
Yes, sir. Degrees of freedom. Yes, sir.
जैनी यार वो एडवर्टाइजमेंट फोटो खींच ली सी हैं मैं कहा
Actually, sir, we have areas table, sir. Areas tables. For already previously what I explained in the class, that is 99.73% we can accept. I told you, no, sir. There we can check the area standard probability value, sir. For t-test, z-test and chi-square test, we have different tabulated values, sir. We have available in the Google also, sir. If you want to know about more, I can share to you, sir.
Okay, ma'am. In your resume, you mentioned expertise in SP, SPS and
Yes, sir.
R programming, madam.
Yes, sir. Yes, sir.
Next time, is there any possibility explain with R program, madam?
Sure, sir, definitely. You can send the topics which you want in your curriculum. Then definitely I can do in hands-on training programs. Why? Because it is open source, no, sir. So it is not a purchase one. So if you have the laboratory, then it is very easy to hands-on training, sir. Hands-on training program.
Okay, madam. Okay. Sure, madam.
Yes, sir. 1 second. Any queries regarding this session? Anybody?
Dr. Putta Rajesh Kumar posted one message, madam.
Okay.
Thank you very much to Allada Suhasini madam for her elaborated and easy way of statistical concept explanation is really very useful for us. I showed this presentation to our 8th semester students in view of biostatistics and research methodology subject.
Thank you so much, sir, for your message. Thank you.
Okay, madam. Is there any doubts? Please post the queries. Okay, it's time for vote of thanks. Very good morning, very good evening, all the participants and resource person Dr. A. Suhasini Garu. This session is very useful for all faculty members and research scholars, madam. Because without hypothesis testing, we cannot explain the results in proper manner, whether it is an acceptable or rejected. Your presentation and demonstration make us more confidence on normal distribution t-test, procedure for testing of hypothesis, acceptance of null hypothesis with a tabulated value, and comparison of results by paired t-test and chi-square test and ANOVA, madam. Very useful for all the students also, madam. Thank you very much, madam. On behalf of principal madam and faculty members, I would like to thank you very much, madam, for accepting our invitation and sharing your knowledge on hypothesis and significance in scientific research. My heartfelt thanks to all the participants for your active participation. I thanks to all the colleagues for your support and cooperation. I thanks to management and principal madam, Vijaya Institute of Pharmaceutical Sciences for Women, for given opportunity to host this faculty development program. Finally, I thanks to all the participants for giving this opportunity. Thank you very much.
Once again, thank you for
Thank you,
everyone
madam.
who participated in this 1 week faculty development program. So this is a good opportunity to all the research scholars, faculty members who are our non-statistics students and everyone. This is very wonderful session organized by the SRK Foundation and Vijaya Institution of Pharmaceutical Sciences for Women. So madam, I special thankful to you ma'am for inviting, and also I thankful to IQAC coordinator who is organizing this session. And I thankful to Dr. Srinivas Garu also for referencing me and everyone. Thank you, one and all. Thank you, sir.
Thank you, madam. Thank you, madam. Shall we close the session? Okay, thank you.